Suddenly my computer is going slower, but it should be visible right now. All right. So greetings to everyone. My name is John Rivers. I'm currently an economist, public administration. I have a specialization in projects of development. I'm working with the Corporation Center of Public Affairs regarding economic analysis and also advisor in the City Hall of Bogota in Colombia, especially advising the topics associated to economic reactivation and coronavirus behavior. And so I want to present this investigation, this research that we did with Dr. Hassan. The name of the research is called First to React is Last to Forget, Evidence from the Stock Market Impact of COVID-19. So we conducted this research together to understand some sort of the impacts associated to the pandemic associated of coronavirus. So I'm going to start with a little abstract. So what was the idea of this research? Well, the idea of this research is considering that COVID-19 has had a parallel and uneven economic shocks across countries since its outbreak in December 2019, the stock market, as usual, were the first to react, with drop rates as much as the global financial crisis of 2008. This study uses daily data to model the dynamic impact of COVID-19 pandemic on the returns of the selected stock market indices and globally traded commodities. I'm going to enable the options right here so I can point out better. So, considering this little idea, the main objective of the investigation was to establish the impact of the COVID-19 pandemic in the US and the stock market returns of the firstly affected countries. As we know, the firstly affected countries were initially China at the end of 2019. Then the first case started to appear on the 1st of January of 2020 in the United States, and then it became spread all over Europe, considering the countries of Spain, Italy, South Korea, and Japan. So the idea of the research is to investigate what was the kind of the behavior or the kind of impact regarding the returns of the first stock markets. So we selected the stock markets accordingly to each country. And this is the stock markets that we selected by each country, considering the prices of each of the stock market. So for China, we selected the FTSE China A50 stock market. For the United States, we consider the Dow Jones stock market. From Italy, we consider the FTSE MIB stock market. Spain, we consider IBAX 35. And South Korea, we consider KOSPI KS 11. From Japan at last, we selected the Nikkei 225 stock markets. So what are the main characteristics of these stock markets? It's usually that the price capitalization is really high in comparison to the rest of the stock markets in each of the countries. So regarding the methodology, to investigate the impact of the contamination rate of COVID-19 on the stock market returns of the firstly affected countries, and also we included some globally traded commodities, we use the form of a k-variate panel vector autoregressive. And the idea of this structural model is given in Abrigo and Love for 2016. So the basic specification comes as equation 1 is presenting. So in the first part of equation 1, we got the vector of stationary dependent variables, which I will further specify which one we included. At the second part of equation 1, we also have the vector of exogenous variables in which we allocate the coronavirus growth rate. And finally, we got the component of fixed effects regarding country effects, right? And finally, the last component of the equation 1 is the stochastic error. So given the general structure of the vector autoregressive, we got in the first hand as y the vector of the dependent stationary variables. So in this case, we included the performance of the stock market of each country, right? So the specification is telling us that the performance of the stock market of country A at time t will become the first endogenous variables inside the model, the panel vector model. So we also include some other endogenous regressors, which are considered the growth rate of the exchange rates, and also the growth rate of the prices of the commodities of gold, platinum, silver, WT, and Brent oil prices. This to have an idea of how was considering the world as a whole regarding the impact of the pandemic. So we also assume some parameter homogeneity, given the parameter associated to the vector of the lagged dependent variables, and also we consider the vector of the exogenous variables, which we allocated the coronavirus inside the model. So why we consider coronavirus as exogenous variables in this case? Well, first, the endogenous system, it is derived from the stock markets as a whole market in the world, which also includes the commodities. So the exogenous variable, coronavirus, is actually not really associated to each of these variables, especially because the financial market doesn't have any physical context, which might explain the contamination in each country, right? Maybe some other markets, like the real production market or the labor market, they might be correlated with the coronavirus. But in this case, since this is only part of the financial markets, it is assumed to be totally exogenous in the regression model. Now, we defined the performance of the stock market, or also the returns of the stock markets, given equation 2. So equation 2 basically just considers for country A at day t the growth rate of the closing price of the stock market. So basically here, as you can see, is the formula of the returns of the stock markets, which we use the closing prices for each of the stock markets, considering as an approximation to the difference of logarithms. Therefore, we use the definition of the stock market performance as the returns, which is the first endogenous variables of interest inside the model. So from the general model, all the variables are taken in a daily periodicity, and they are structured in growth rates. So we had to analyze the unit roots and the integration order of each of the variables. According to this, and allowing to have a significant sample size regarding the time window of analysis, we use daily data from 2015 to 2020. Specifically, we use data from 1st of January of 2015 to the 1st of April of 2020. And in order to have this large sample size regarding the time window, we have the advantage that Beck and Katz established regarding that the average error term minimizes to 0 when t tends to infinity, eliminating the bias of the dynamic panel data models. So, from the general VAR, we estimate different types of estimation as a robustness checks, right? After we confirm the stationarity condition of each of the variables. So we perform as first the panel least squares method, and then we perform the White-Arellano estimator with the cross-section weights in order to account for heteroscedasticity and serial correlation. We also perform the Driscoll-Gray robust standard errors in equation 1 for accounting for the same issues of heteroscedasticity and serial correlation, but also we want to account for the influence of cross-sectional dependencies in the regression structure. Finally, we also did some seemingly unrelated regression models with the form of the generalized least squares method to confirm the presence of the cross-sectional dependency with a Lagrange multiplier test. So in the end, the best and suitable regression technique was the Driscoll-Gray, because the errors showed some heteroscedasticity and some serial correlation, but also it has the influence of cross-sectional dependency. So the Driscoll-Gray robust standard errors are known to be robust to these three types of problems inside the regression analysis. Now, I want to show you some context regarding the investigation. So first, I want to present you the behavior of the daily prices of the stock markets on the time window. Now, I want you to consider the last part given right here, which is in from 2020 in January. So as you can see, China FTSA has a significant drop rate at the beginning of the year 2020, while the last year it was with an increasing trend, right? The same happened to the United States. United States was having a trend, a positive trend in 2019, but as soon as the contamination spread over the United States, then the returns of the stock markets and the prices, the overall prices, dropped down significantly. So I want you to check the magnitude of how hard it was to keep the price of each of these stock markets. As you can see, the China stock markets did not drop as hard as it did the Dow Jones. So this is kind of explained also by the contamination of the coronavirus. So moving ahead with the rest of the countries, all of the countries experimented the same behavior, a significant drop rate in the prices of each of the stock markets as the beginning of 2020 was starting. So these different magnitudes were commonly associated in the performance of the stock markets and also the daily prices. The same happens to the Asian countries of the analysis, which are South Korea and Japan. There is significant drop rates of the prices of each of the stock markets at the beginning of 2020 to the 1st of April of 2020, which is the period of analysis. Now let's see the behavior of the infection by country. So the infection by country started in China up to this point, according to the Johns Hopkins University, but it was controlled pretty fast. As you can see, by the second month, that is February of 2020, it was already controlled the spread of the virus, right? While in the United States, up to this point, in March, it started to grow. It hasn't been controlled. So remember when I told you that keep in mind that the drop of the prices of the stock market was associated to the level of the infection? This is part of the case. The China prices of the stock markets did not drop as fast because they controlled the infection pretty fast. But in comparison, the United States, up to this point of analysis regarding April, March, it did not control the infection. Therefore, the drop rates in the exchange and the stock market's performance were dropping down. The same happens for Italy and Spain, and it also happens for South Korea and Japan. So this is the common behavior across countries. The only country that contained the coronavirus infection was China, and that may explain why the magnitude of the decreasing prices of the stock market was differential for the country. Now, regarding the behavior of the commodities, there is some special case regarding the gold. So the gold, in right here in blue, it did not present a drop rate as the other commodities. For example, platinum right here presented a significant drop rate after the 1st of January of 2020. But from the rest, the gold prices remained some sort of stable, right? Now, the other commodities, just as silver and Brent price, with also WTI oil, had a significant drop. So this is part of the influence also of the coronavirus, but it also has some sort of the effect associated to the economic situation that happened in the oil producers' country. But something that I want you to keep in mind before we proceed is the gold behavior, because the gold and also the exchange rate, they have some properties regarding to be a safety value. Yes, the investments usually invest on gold when there are uncertainty in the markets and maybe some highly risky situations. So this property of the gold and the exchange rate makes some sort of the explanation that why it did not drop the price in overall during the pandemic. So this is something to keep in mind, because in the regressions, it was not statistically significant to explain the behavior of the gold price. So here is some correlation analysis regarding the growth rates. This is in growth rates in order to avoid a spurious correlation given the inertial effects of the time series. So let's start with the column 1. So column 1 is associating the stock market performance in overall for all the country of analysis in all the time, and then presents the rest of the variables. So notice that the contamination growth rate of COVID-19 is statistically significant and negative correlated with the performance of the stock market regarding this analysis. And the exchange rate is not statistically significant in this case. The gold prices are, and the rest of the commodities are. So now I want to check column 2, because column 2 will have the contamination growth rate. And contamination growth rate will have negative significant effects in the oil prices commodities, such as silver, platinum, oil, WTI price, and Brent, and oil price of the Brent. Yes. Considering this is always in growth rates. So this is the kind of effect that we can see empirically from the coronavirus spread over all the countries in the analysis. There is a negative effect regarding the behavior of the prices of these commodities, but also the performance of the stock markets, given the analysis of column 1. So what are the main results from the regression of the equation 1 regarding the 4 types of techniques? The first result is that the variables are stationary, since they were taken in growth rates, according to the first and second generation of panel unit roots. The panel least squares, the seemingly unrelated regression, and the Driscoll-Gray regressions reflects a negative impact of 2.3% on the stock market returns on average by all countries. This giving an increase of 1% of the coronavirus infection growth rate. This is statistically significant in all models at 1%. The only difference regarding all the regressions that we perform is that the white Arellano estimator with the cross-section weights reflect a slightly change in the magnitude of the impact. Instead of the negative impact of 2.3%, it was actually a negative impact of 2.1%, still significant at a 1%. Now, the coronavirus growth rate was not statistically significant to explain the changes in the exchange rate and the gold prices. That was the overall result across the regressions in the models. And however, at a 10% level of significance, it explains negative changes in the commodities of platinum, negative associated at a decrease of 1.1%, for silver at 1.6% of decrease, WTI 3.26%, and Brent 4.08 decrease in the prices. So this is the overall impact of COVID-19 with the numerical results given the regressions. They were consistent across the regressions and across the models. And now we perform some granular causality tests since we used the panel vector structure. We found that the exchange rate, the platinum, and the gold are a granular cause of the stock market returns at the 10% level of significance. The stock market returns on the platinum granular causes the exchange rate at the 5% level of significance. WTI oil price granular causes the gold at a 5% level of significance, and at a 10% level of significance, the exchange rate and Brent oil prices granular causes the behavior of the gold, the Brent, and the WTI. Finally, the gold granular is a cause platinum at the 5% level of significance. All the variables are a granular cause of the silver at a 1% level of significance. The silver alone only granular causes the WTO prices, while the Brent is a granular cause by the exchange rate at a 5% level of significance. We analyzed the impulse response from the panel vector autoregressive structure, and we found out that after one Cholesky standard deviation shock, each variable had a response of its own, but there is a decreasing effect which disappears after 8 to 10 days. So this is kind of the effect associated to working with growth rates in the stationary context for all the variables. There are no permanent effects. But there are some interesting notes regarding the impulse response analysis. For example, the gold prices react positively to a shock of the stock market returns, but the effect is not permanent. For example, other result was that the platinum and the silver commodities tend to behave similarly for a longer period of time, but the response of the positive shocks usually fade away after 4 days. A shock in the stock market returns triggered the short-term positive responses of WTI and Brent oil prices. And finally, a positive shock in the WTI prices creates a stabilization process for the same variable in the short term, while the same shock triggers a positive response in the Brent oil prices. Finally, the silver responds positively to a shock in the stock market returns. However, after a few days, the response turns negative and then later insignificant. So this is the overall conclusions. Thank you very much for your time. If you have further questions, please ask.
Thank you, John, for this interesting paper. Actually, it's really interesting research that you and Dr. Hassan has conducted. I just want to know that what kind of policy measure that you suggest through this research, like how countries can, try to mitigate the impact on their stock market. What kind of policy recommendation you have through this research?
Well, I would suggest that the best idea is to control the contamination spread of the virus, but I would not say general lockdowns, no. But because, for example, the best example that we got right here of the policy effect is the behavior of China. For example, as you can see right here, China did not present a significant drop rate in the China FTSE stock market, as it is, for example, the United States. And this is part of how China handled the contamination and spread of the virus. Because in the overall graphs, which presents the overall contamination of coronavirus, China controlled pretty fast. It slowered the acceleration of the virus in at least 1 month, and they do this with specific lockdowns. Yes, there was no general lockdowns. It was in Wuhan. So this is part of the results of how to control and how to mitigate this inconvenience of the coronavirus in the stock markets. I would say this is the best policy effect which China implemented already.
Excellent, excellent. Anyone has any question, comment, or feedback on this research? I think Dr. Hassan has also joined. So Dr. Hassan, let me see. So if there is no question, then we can start with other paper.